Okay, my dear students, welcome back. So, in this video, we will find the Laplace transform of a periodic function. So, suppose we have a periodic function ft and say it has a period capital T. Okay, so or in other language you can say that this function of t plus capital T will be same as function of t, right? So both languages are fine. Some books, some authors, they prefer to write directly that f is a periodic function with period t, and some authors they prefer to write that ft is a function such that f of t plus t is equal to f of t plus capital T is equal to ft. So it is understood that okay, yes, it means the function is a periodic function with period t. Okay, and for a periodic function the Laplace transform is given as 1 over 1 minus e to the power minus s capital T, which is the period of this periodic function, integral 0 to capital T e power minus st ft dt. So this is the formula for finding the Laplace transform of a periodic function. Now let us take a function which is periodic and let us find its Laplace transform. Question: find the Laplace transform of the periodic function ft is equal to cosine t with period 2 pi. Okay. So Laplace transform of ft, which is a periodic function, is given by 1 over 1 minus e power minus s capital T, which is the period of the periodic function. In this question, this capital T is equal to 2 pi. Integral 0 to t, again this capital T is equal to 2 pi e to the power minus s t ft dt. So here in this question, capital T is equal to 2 pi. This is the value of capital T, which is the period of this function. So we can replace capital T by 2 pi. Integration 0 to capital T, this also you can replace by 2 pi. And ft, our function ft is cosine t, right? Now, integration by parts will be used to find this integral, right? Otherwise, you can use the formula directly, the very famous formula which you have already in place. That is, let me write the formula somewhere in the corner. Integration of e to the power ax cosine bx dx is equal to e to the power ax divided by a square plus b square a cosine bx plus b sine bx. I have written it in terms of x. You can also write it in terms of t. So, using this formula, we get 1 over 1 minus e to the power minus 2 pi s, and this integral e to the power minus st cosine t. If you see here, my a will be equal to minus s and our b will be equal to 1, right? So, the formula will give us e to the power ax. In place of x, we have t, right? So, e to the power a, that is minus s, x, we have t in place of x, right? Our variable is t. Divided by a square, that will be minus s whole square plus b square, that will be 1 square. A cosine bx is minus s cosine bx. In place of x, we have t and b is equal to 1, right? Plus b, that is again 1, sine b, that is again 1, x. In place of x, we are using t. That's all. And the limits are 0 to 2 pi. So we have used the formula okay. Now let us put the limits and let us get the answer. So 1 over 1 minus e to the power minus 2 pi s, and if you observe here, this part, there is no t here, so you can shift it outside the bracket. So this will become minus s whole square, that is s square, plus 1 square, that is 1, right? And inside the bracket you have e power minus st minus s cosine t plus sine t, and we will put the limit 0 to 2 pi. Okay, now let us start putting the limits. So we get 1 minus e to the power minus 2 pi s square plus 1 and now first we are going to put t equal to 2 pi. So we get e to the power minus s times 2 pi minus s cosine 2 pi plus sine 2 pi, right? Then we will put t equal to 0. So this gives us e to the power minus s times 0. Let me write in this form. In the next step, we will put all the values. Then minus s cosine 0 plus sine 0, bracket closed. Okay, that's all. This will give us 1 over 1 minus e to the power minus 2 pi s multiplied by s square plus 1. Now, e to the power minus 2 pi s, inside the bracket we have here cosine 2 pi. Cosine 2 pi is equal to 1. We have sine 2 pi, that is equal to 0. We have cosine 0, that is also equal to 1, and we have sine 0, that is equal to 0. So this term becomes 0, this term also becomes 0. So we get minus s times cosine 2 pi, that is 1. So this will become minus s, and minus e to the power 0, that is again 1. And inside the bracket we have minus s multiplied by cosine 0, that is 1. So that is again minus s. So we are now in a position to write the final answer. This gives me 1 over 1 minus e to the power minus 2 pi s multiplied by s square plus 1. This gives me minus s e to the power minus 2 pi s, and this minus 1 times minus s will become plus s. So this is the Laplace transform of this periodic function. So this is all for this video. I hope this was clear, and in the next video I will come back with some other topic. So we will meet again very soon. Take care all of you. Bye.